Here's a bit of a recap from last time, from GeForce Cables Melting 1, A New Hope, and I don't know. When the 4090 launched, we saw lots of reports of cables melting. NVIDIA, their story pretty much boiled down to it being user error, either people seating the cable incorrectly or installing poorly constructed third-party cables. Part of the issue was that to get their fancy new connector to fit in a lot of cases with the way that it stuck out directly off the top of the card, the cable ended up pressed against the side panel, straining the connection. Now, CableMod made some 90-degree adapters that people hoped would fix the problem, but long story short, they didn't, and CableMod ultimately recalled said product. Newer 4090 models attempt to solve the issue by repositioning the 16-pin power connector. Also, the 12-volt high-power cable design was updated to 12-volt 2x6 for 2025. It has shorter sense pins and longer conductor terminals to help ensure that all of the power carrying cables are all the way in before the sense pins will say, hey, yeah, we've got a connection. Corsair currently has at least 6 blog posts about 12-volt 2x6 or 12-volt high power, which adapter you should use, and how to connect cables to your power supply. Now, I'm going to take a moment here and go off the sort of notes provided to us and say, hey, if something's this complicated, is the problem maybe you and not me? Anyway, sorry. I digress. Reports of more failures with the 4090 and adapters continue to pop up all the way into 2025. PC Gamer ran an article in April last year stating that one repair shop in the LA area saw about 200 cards and adapters with melted connectors over a 1-month period. Wow. And Tom's Hardware ran an article yesterday called The Dark Side of Gaming, finding that their 2-year-old card's connector had been melting, despite no obvious performance issues. Now, it's time to fast forward to a day after yesterday. And it's time to talk about the 5090. We are now seeing more reports of cables melting. Reddit user Ivan6953 made a post a few days ago showing melting on both ends of the connector. Ivan claims that it was securely fastened and clicked, and that he was using an older Mod DIY third-party cable. Mod DIY has released a statement that you should upgrade to the latest 12-volt 2x6 cables for RTX 50 series cards. YouTuber Toro Tocho, let's go with that, reviews, released a video on February 9th claiming that the wiring burned due to a bad connection because of wear on the 12-volt high-power connector. States that the power supply was very used. Der Bauer has tested one Founders Edition card, so it's a 5090, with one Corsair cable, and says that there was uneven current distribution across each pin. And this is where things start to get a little bit complicated. Yeah. And where things start to get a little bit drama-y. So, the connector is rated for 9.5 amps per power pin and 1 amp per signal pin. Okay? Der Bauer saw readings over 9.5 amps. In fact, in his first video, he saw over 20 amps on one wire. Then, Johnny Guru, who works at Corsair and used to be kind of the power supply reviewing guy back before he worked at Corsair, said that was impossible. In Der Bauer's second video, he said, I will show you what is possible, and cut 4 wires while the card was under load, measuring about 50 amps between the remaining 2 wires, demonstrating that while that is not, in fact, something that you should do and is not representative of a real-world situation, hopefully, that it can, in fact, run more than 9.5 amps over one wire. He said that it still worked because the sensing pins only check to see if the sensing pins are plugged in. And if they are, the card will try to draw whatever power it's supposed to. It doesn't check how many power pins are connected. And you can see that about 12 minutes into his video if you check for yourself. Dan, do you want to throw that in the various chats? It's the one that's hyperlinked in our notes here. He then plugged in a new undamaged 12-volt high-power cable from Corsair, and the load was distributed evenly. So what he has kind of shown kind of validates what some others have said, and that is that this might just come down to bad cables. But what he has also shown is that there's still a problem, because you can't guarantee...
One quick set.
Yeah.
Did you say that he cut the cables while it was under load?
That's what my notes say.
People are saying that it was...
Oh, sorry, he cut the 4 wires and then... Sorry, no, not while it was actually on. That would be crazy. Let's back up a bit. He cut the 4 wires and then measured the remaining 2 wires with a current clamp while it was under load. Sorry. All right, cool, good. So he's demonstrated 2 things. One, that the issue could very well be, bad cables, not necessarily bad cards, but also that it seems to go a little bit deeper than that, because if a card that is good can't tell that a cable's bad, well, that could be an issue, couldn't it? So this is where the plot thickens. Roman goes on to say, this is Der Roman, that this wasn't a problem on the 3090 Ti because it had monitoring and load balancing built into its power delivery design, while 40 and 50 series cards do not. More on this from Buildzoid later. Some others have sort of weighed in. Falcon Northwest are adamant they haven't seen any issues in the systems they've been building and testing with similar equipment. But according to Buildzoid, with the 30 series, there were 3 shunt resistors and 3 power phases, similar to how a 3x8 pin system would work. While with the 4090 and 5090, they only have 2 shunt resistors and 1 power phase. So the way to kind of explain this is that the 5090 has no way of knowing or monitoring which of the 12-volt cables that are plugged into it is actually bringing the power into the board. They all just join on the board. So all it knows is, hey, I'm getting power. And you might think, okay, well, a simple solution to this would be for NVIDIA to put some kind of thermal probe on the connector side of the card. But the problem is that these are toasty cards. You'd be getting so much heat off of the GPU and the memory and the VRMs that could potentially, tell those thermal probes, oh yeah, everything's, running really hot. That they wouldn't be able to tell if it's because the cable that's plugged right into it is on the verge of melting, or if it's just that the card runs pretty freaking hot because it's a 5090. Yeah. I don't know. Do we have our CT scanner time? Oh, okay. Hold on a second. Blah, blah, blah. NVIDIA, for their part, I did reach out. NVIDIA has said, well, here's the situation. I'm paraphrasing here because this is not official, but they're basically we don't have any of these cards back yet. We need them back so that we can do failure analysis on them, and that's fair enough. But I am sort of worried for NVIDIA's sake here that when they get them back, what they're going to find is that if someone plugs in a defective or poorly positioned, poorly seated cable, that they have not built the appropriate mitigations into this card, and it could continue to be a problem. They do say that very few cards have been impacted, but that doesn't mean that very few cards will ever be impacted. Okay. Oh, this is awesome. So it's CT scanner time. We CT scanned a 3090 Founders Edition, a 4090 Founders Edition, and a 5090 Founders Edition. Below are the scans. They will all have a bookmark in the bottom left panel called 12-volt high-power connections, which will show the connections to the board. Okay, these scans are 10 out of 10, but I took bad screenshots in a Google Drive here. You can't quite make out PCB components. All right, so I am seeing these for the first time because they've been working on this in the lead up to WAN show. So good luck, everybody. Oh, these are going to take a minute to load. So here's a 3090.
Mine has maybe loaded faster.
Oh, okay, let's go over to Luke's screen. Sick. And basically, what we're looking at is this one looks like it's split into 2 groups. There should be a bookmark, a view.
Here? Front view PCB, paper chamber. This is the power connectors.
Okay. Yeah, good. Yeah, you want to flip it over?
Traces pads? Oh, here?
There we go. Nope, not that one.
I don't think so.
Okay, go back to the 12 volt high power. Okay, I got someone in chat saying that looks like 3 shunt resistors to me. The claim from Buildzoid is that 3090 should have 3. So I guess that lines up.
Okay.
Okay. All right. Now let's go to the 4090. Have you opened that one already?
No.
I'll click it now. Man, I love this CT scanner. This is so cool.
I'm going to preload 5090.
Perfect. Okay, we're coming back to my screen. Yeah, neat is definitely an understatement.
It takes a hot minute to load. Just give
Yeah,
us a
sorry
sec.
guys. This is a really rough scan, but the pins are separate at least from the connectors. What our notes say here. That is a pretty rough scan. Okay. There we go. Where's our... Okay, da-da-da-da. Okay, so this one... Yeah, that is a much rougher scan. Let's turn our attention to the 5090 because Lucas showed me this one before the show. Okay.
So this is the... Oh, do you want to do mine? I have it already.
Yeah, go for it. So here, the issue is that the connections are all just tied together into a single bus. So what Lucas was showing me before is that basically all the 12 volt pins just go into a single power plane, and all of the ground pins just go into a single ground plane. So what this means is that the board has no way of knowing which pin is carrying all the power in. So if one of them has a poor connection, one pin has a poor connection, then what will happen is that pin will heat up. The more it heats up, the higher the resistance goes, so the worse the situation gets. Then you can have the connector start to melt, which obviously is not good for the contact of the pins. And all the while, all the card will see is, I am getting power. Not good. Isaret in the float plane chat says, Linus, so if you have common power planes, why use a connector that is prone to differential amperage due to resistance? Well, let me tell you, you'll have to ask NVIDIA that.
Yeah.
Their board partners don't appear to be doing so. Buildzoid's diagram shows that the RTX 4090 Matrix and 5090 Astral both actually use a different approach that would allow it to detect if one of the pins is carrying too much amperage. This doesn't look great. The only defense that I can see for NVIDIA in all of this is that this power connector is technically part of the CM5 industry standard and should be safe at power levels up to 600 watts. But here's the thing, Luke. I remember back when we transitioned to this thing, with several people, I've had this conversation several times. I believe we've also talked about it on WAN Show. With my limited understanding of electrical engineering and electronics engineering, what I know,
both dropouts, by the way,
is that more surface area, more the better.
Right.
When it comes to mating surfaces for an electrical connection.
Sure. Yeah.
So why was it that when NVIDIA recognized that we were moving to a point where GPUs were going to require more and more power, what possessed them to go for smaller little tiny pins instead of the big pins we had already?
Yeah, I don't know.
I still don't understand that, and I have yet to have anybody explain it to me. If we moved, say, to 24 volt at the same time, sure, I'd be far less concerned. But we didn't. So what and like NVIDIA is the one entity, other than Intel, sure, Intel as well. NVIDIA and Intel are the two entities that can sort of just declare that we are going to use a new connector. You know, they need some.
Intel can still do that. Historically, maybe.
I mean, they are the maintainers of the ATX spec. So, you know, there is that. But
okay.
Anyway. Okay, historically then. Intel and NVIDIA to just unilaterally make a decision that we're going to use this connector now. So they could have decided on any connector. They could have designed, you know, with a consortium or with some input from others. They could have designed their own connector. We could have gone with, you know, some variant of the larger, older style pins that are also used in CPU power connectors, EPS, ATX, 12 volt, all that stuff. They could have used those same pins and receptacles, and they could have added the sensing wires that are actually a pretty cool part of the spec, because as long as people don't just jumper them to fool them, theoretically they communicate between the power supply and the GPU so that you don't have a mismatch where you've got a super hungry GPU and an inadequate power supply. That's the theory behind it. But the whole thing where the new connector was, you know, like rated for more than the old connector, to my like monkey brain, I'm kind of looking at it going, why?
Yeah, why was that?
Why exactly was that when you've got this obvious potential issue here? Super Whisk says, why not just have a connector with two giant spades if it's going to be that way on the inside? Yes.
Yeah, kind of.
Yeah.
I can't claim to know. So much of this is just like, it seems obvious to me, but I don't know a lot about this. So I'm assuming there's like gotta be something else going on. Like
I bought a bunch of these RC LiPo battery connectors. I forget what they're called. XT60s and XT90s. Like if you're gonna design the card like that, why don't we just use these? These things are sick.
Very chunky.
These things are great, and they like won't. Yeah. Jape Fife says the XT60 connector can do 30 amps at 500 volts. Yeah, why don't we just use that? Because, like, yeah, you're going to have the same issue where if it's not connected properly or whatever, then you won't have the same issue because you've just got two giant pins.
Yeah. So you should plug in just fine, really.
So you can't have one pin have a bad connection.
There's
and
a good amount of space separation between those two.
Yeah, why don't we just use that?
And stuff.
Cami Hudson says XT60 is used in my solar panels. They can carry a lot of power. Yeah. Okay, there. All right, there. That's the LTT solution. We're going to move away from the old PCIe connectors. We're going to move away from 12 volt high power. We're going to move away from all this stuff, and we're going to go to XT60s. If we're not going to have protections on it anyway, then we might as well just have a big old. I mean, look, why don't we just go for a wall outlet? I think it would look
kind of cool.
Let's just plug it straight into the wall.
I mean, there was tons of memes about that.
Yeah.
Like tons of them, especially if you can plug that wall outlet in on the back of your computer. And you know, when they have these, bridging PCBs like they do on the dual flow-through design, you could move the plug lower in the case.
Tynan says, you're still in trouble, Linus, because the current into a 5090 is like 50 amps. Okay, Tynan. I will see your 50 amps and I will raise you one XT60 connector. Dual XT60 connector. It's almost like we had a solution for this before, where you just have multiple connectors if you need more current. We could also just go to XT90. How many amps can XT90 do? Hold on, XT. That thing is chunk. That thing's chunk. Are they safe for... The rated current is just 40 amps. However, the response on ESK8 forum says I wouldn't worry about drawing more than that. The XT... someone else says they're spec'd at 90 amps for the applicable RC power range, which is generally low voltages of 11 to 24. Okay, so why don't we just go to XT90?
What about something like Speak-On? Have you seen a Speak-On connector?
You're going to have to give me the spelling.
Speak-On, one word.
Oh, okay, sure.
I think I found it.
I mean, yeah.
And they just twist, lock in, and click.
Let's go. And you can get professional ones.
These are actually huge.
For $6.25.
These are enormous.
No problem.
These are so big.
That'll be your 6090.
Let's connect a water hose to my graphics card.
Pretty much.
I don't know, man. NVIDIA might have some defense for this. I don't know what it'll be, but I just don't see how, after all this drama, it just didn't seem obvious that these are fragile little pins and we just shouldn't. And again, I'm not an engineer, but it just seems obvious. And it's one of those things where not only does it seem obvious, because sometimes science is a funny little bitch sometimes, where something can seem very obvious to the layperson, but when you get into the actual science of it, that seemingly obvious explanation is totally stupid, right? But not only did this seem obvious at the time, but it has worked out that it was bad. We have seen in the real world that can we just stop? Is that an option? Maybe NVIDIA could this would be a great mitigation. NVIDIA could call up all their partners tomorrow and say, hey, it. Put whatever power connectors you want on the new card designs.
Yeah.
We're over it. We're over it.
So they can keep this with their FEs, but everybody else can move on.
Because every power supply still needs to have PCIe power connectors on it for older GPUs and for AMD GPU. AMD hasn't adopted the standard, and neither has Intel, who maybe even is a relevant player at this point.
Maybe.
So 2 of the 3 relevant players in discrete GPUs have not adopted the 12-volt high power or 12-volt 2x6. So it's not like the whole industry moved on and, oh my goodness, everyone who bought a power supply in the last couple of years it's a brick now because they're not going to be able to plug in the RTX 6090 or whatever. No, everyone still has PCIe power connectors. So,
yep.
So NVIDIA they could call up all their partners and just say, okay, forget it. Use whatever you want. We're going to do our thing or whatever because all the power supplies still support this connector. Or better yet, we could just not. Sorry that we were such control freaks about this. Maybe we shouldn't have been, because this honestly didn't work out too good.